Good evening, folks. Is to say nobody yet in chat. I don't know. Like I feel like when you're I've talked about this before, but like when you're streaming, you're supposed to like have a waiting room for people to show up so that they can like be here when the interesting content starts. But like when you're doing a YouTube video, you kind of don't want to sit around doing nothing at the beginning. So I don't know. What I should do is like set up a stream starting soon, like waiting room background or overlay or something. But like God, what a pain, right? So we're gonna do days 14 and 15 today. I looked over them; they should both be achievable. I'm also going to revisit day 13 a little bit, just to talk about a little change that I made in between that stream and this one. Was it a stream? It was, right? Maybe it was a video. I don't know. I think it was a stream though. But I'm gonna do that later, I think, just so like I don't know, whatever. I think we'll start with day 14 here. Right? Sure, why not? Okay, let's do day 14. Here we go. Extended polymerization. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules. You just need to work out what polymer would result after repeating the pair insertion process a few times. So it gives us our example here of this is the starting state, and basically each adjacent pair produces something new in the middle of it. I already read this. So we add a C in between the two N's. We add a B in between the N and the C. And we add an H in between the C and the B, which are apparently in this rule somewhere. And so we end up with this. And so the kind of anyway, then they say, what do you get if you take the quantity of the most common element and subtract the quantity of the least common element? So notably, they're not asking me like, what is the total polymer? And what is like sort of glaringly obvious about this is that it is exponential in nature, right? Even if we didn't count overlaps, like if we just put something in between the two N's and then between the C and the B, we would be multiplying our size by 1.5 each iteration, which is exponential, and therefore for any largest number it would be expensive. But it's worse than that because we're actually like doubling, right? -1. 4 to 7, 7 to 13, 13 to 25, and is that right? $12? Right, something isn't quite right about that. Why isn't it doubling -1? 7, we should be adding 6 to the 7. We are, or that's 13. Oh, it should be 25. It's 12 more. Yeah, okay. So, right. We're roughly doubling the length of the input every time. And they're saying apply 10 steps. Fine. That's not hard. 2 to the 10th, right? But these kinds of problems, typically, they say, well, this is like lanternfish redux, right? Or angler lanternfish is what they were called, right? Where you had to recognize that you shouldn't simulate the entire process because it doesn't, because the participants in it are indistinguishable, they're fungible, right? And here, they're not quite fungible because order could matter. It won't matter for the question they're asking us here, though, right? And so we can simulate them in groups, just like we did with the lanternfish. Now, in principle, part 2 might be, all right, run it for 10 steps and then tell me the whole string or something stupid like that. But Eric never wants us to put in more than 8 characters, so that won't be it. And also, that's like kind of just rewarding you for doing the easy, obvious thing instead of thinking about the problem. And so presumably part 2 will be like, run it for 100 steps and then tell me the answer, right? Also, like I read the subreddit, and part 2 is to run it for more steps. So, you know, okay, we cheated a little bit there. But that wouldn't be a big surprise, even if I hadn't read it. So, what we can do is observe that any pair of NN, for example, wherever it is in the string, it's the same as any other pair of NN. Right? We can just keep a map where we say how many NNs are there. And each NN will turn into NCN, and that means we'll have an NC and a CN. But that'll happen no matter where they are in the string. So we can basically break the string into pairs, group the pairs by their, I guess you could say by their identity, by their equivalence partition or whatever, and just count how many of each pair there are in each step. So we process all instances of a given pair at the same time. So that's going to be the plan for today. Let me grab my input here. Yeah, kind of long. And all of them do produce only one output, but if they produced more than one, that would also not be a big challenge, I think. All right. So do I have? Yeah, you guys are looking at the right thing. Day 14 and cat input.text. There you go. Here we are in day 14. I don't know. My template has a bunch of stuff I don't use anymore, but I'm not going to fix it. I should consider writing a better main, because I've a couple times this year this main has just kind of sucked. You want to output a string or something, right? Or if you want to do anything at all complicated, but whatever. So what types do we need? Well, we need data. What do they call these? Polymers or something? Polymer, template, pair insertion. They're elements, I guess, technically. Yeah. So let's define new type element is element of char. Deriving, you know, we're going to need at least eq and ord, and show wouldn't hurt. And a new type? Or do I want a data? I guess I'll just define data pair. I don't particularly see a reason why making it a new type around a tuple would be particularly exciting. Data pair is a, well, I mean, let's let it be polymorphic just in case that's useful for some reason. We're going to be working with pairs of elements, but maybe for some reason we'll want a pair of functions or something at some point. And yeah, okay. And the other thing we need is a data, what do they call these? Rules? Sure, rule of A, I guess. The rule of pair of A and A. And we shouldn't actually need much of anything for this, right? I guess it would be fine for this to be in a map as well. Because we're going to have a pair in hand that we looked... No. I mean, I guess I want a rule of A really just for long enough to put it into, like, to read it from the input. The input is going to be a list of of rules, basically. A list of elements and a list of rules. And then I'm going to turn that list of rules into a map. And so I won't anymore have a single value that's the pair and the output. I'll have a map from pair to element. So we shouldn't need eq or ord or anything for the rule itself. Let's import data qualified data map strict as m. I think that's sort of all the types that I want at the moment. I can define a type alias for, like, map from rule to pair and map from pair to int or something, but I think that just using those types longhand should be fine. Import text regex applicative again. I shouldn't need common because there's no ints today. And my int, I guess I need a data type for my input, of course. Data input is an input containing first a list of element and then a list of rule of element, right? So let's write a parser for it. Type regex a equals re char of a. Rule, let's say, is a regex of rule of element. We do have to be specific here that it's going to be it can't be just a rule of A, because we're going to actually be reading strings or chars from the input. So, you know, what if I just don't do all this dumb stuff and just define the whole thing as one big old nested, like I did before, just a bunch of where clause, a big old where clause in prepare, right? Prepare equals well, okay, fine. From maybe of input empty empty of equal tilde input, basically. So I'll say if the input fails to match, just give me an empty input, because handling errors is too complicated. Where input is input of many element, really should be some element, I guess, but whatever. And then we're going to ignore string new line new line. And then we're going to actually read many rule, right? Yeah, that seems fine. And element is very simple. It's just element of psim of, how do I say it's an uppercase character? 52 of and is alpha and is upper. Actually, it might just be upper is upper. Let's look up the type real quick of is upper. What's uppercase or typecase alphabetic Unicode characters? Okay. So I think that means that it. Yeah, I guess it makes sense. It's fine to call these upper on like the number 5, and it'll just say false, right? Let's check that in GHCI real quick. Import data char is upper of 5. No. Okay, is upper of J. True. Okay, cool. Actually, I don't need all this nonsense. psim is upper, right? That seems fine. And rule is maybe our most interesting one, but not all that complicated. Rule of... Do I have a type for pair? I do, right? Rule of pair. And then... Oops. I'm going to ignore a string. What does this look like? Pointing to the right. And then another element, right? And we need a parser for pairs. Element. Cool. So nothing too fancy here. Now it shouldn't compile because there's various places I've not written stuff. Okay, so from maybe is upper we need import data char is upper, import data maybe from maybe. Really? Just warnings? Oh, yeah, I guess that's true. I'm done writing prepare. And so the input types match up. Okay, yeah, it is just warnings. Okay. Let's get a DHCI shell in the right place so that we can test prepare of... This won't be showable, will it? Because I didn't put show on all on input. So I expected ABC, new line, AB, Q, new line. Ah, I forgot the extra new line. There you go. So a pair is all of the, a rule is all of this, and then also an ignored sim of new line. And then we have also a rule that BC goes to J, let's say. Cool. This parses just fine. 3 elements. And a rule that the pair AB goes to Q, and a rule that the pair BC goes to J. So let's prepare, just confirm that it actually reads our input, and it does. Great. Okay. Cool. We could even commit that, couldn't we? I mean, like, I don't usually bother to do this, and this wasn't a complicated enough parser to really warrant it, but for some reason I feel like it. Git commit -m day 14 types and parser. There you go. So we need it's kind of annoying, isn't it, that our input is this list of element when it would make more sense if it were a list of pairs already. If we had a map of like pairs of things. Let's go ahead, I guess, and say type polymer is a map from polymer A? I don't know. Map from pair of A to int, right? That's what I really want. Oops, bumped the table there. And so instead of a list of element, we should really produce a polymer of element. We should already have built the map saying here's how many of each pair there are, right? So from maybe of this is not quite right anymore. So let's put, the input needs a polymer now, and a polymer is something, right? We're going to take many element, and then we're going to map a function over it. We'll say mk polymer or something, I guess. Where mk, I could make polymer in the outer where, but I kind of like it as being obviously internal to this. Or make polymer of ease is m dot from list with plus, add them together. We're basically gonna create each pair associated with one, and then let the map merge them so that if there's multiples, we get a larger number. M dot from list plus of zip with entry ease tail ease, and entry of AB, I guess, is equal to pair AB1. Does this compile at all? I misspelled tail. Okay, you got me on that one. What else? Couldn't match type. Oh, it's not a... pair AA. Why is many lit up, by the way? I just don't believe HLS at all. Let's ask GHCI. I'm sure you're right. Okay. Oh, from maybe I didn't fix that. There you go. Mempty. How about that? So I fixed that problem. Now I have a list of element. I have a parser for element, and expected for some reason a parser of list of tuples. Many element is a parser saying many element actually has type list of pair, but it shouldn't. It should be list of element, right? So yes, I agree with you that that's wrong. Why does many element have type list of? Okay, basically I guess it's because make polymer is badly implemented and it's inferred the wrong type for make polymer and therefore the wrong type for element. So let's just say, so that QC will know how to help me, I'll say, this is supposed to be an RE of char to, did I call this type polymer or something? Yeah. This is supposed to be a parser for polymer of element, please. And with that hint, I get the same bug. Very funny. Make polymer of many element. That seems right. Oops. I did something really wrong here, huh? Element is a parser for elements. That seems okay. Many element is a parser for list of elements, I'm fairly sure. Have I forgotten the type of from list with? I don't think I have, but let's check. From list with, and if we look at this in the map docs, it just wants a function for combining values and a list of pair of key and value. And that's what I should have. Zip with entry. Oh, you dummy. Zip with doesn't want a tuple. It wants 2 arguments. Okay. So everything's happy now. And if we go back to GHCI and I say prepare this, it says, you have an AB once and a BC once. And if I said ABC or AB, if I said I had AB, AB, C, it would say, well, you have AB twice, BA once, and so on. So that's great. That's what we wanted. Let's go ahead and just like recommit that. Why do I have all those blank lines? I don't know. I was about to start explaining more stuff and I did. All right. So now we're back to having a parser that does what we want, except that what we want is more sophisticated and we still get it. Great. So the main thing then that I need, actually, why is my input a list of rule element, right? The whole point was we were going to then turn this into a map from like pair of A to A, right? So maybe what we could do is make our input also take a, instead of a list of rules, it could take a function from pair A to A, and that function would be backed by a map. We could just make it take a map directly, but I don't want to. So let's define another type. Well, whatever, I don't need that. And it's going to take our input will contain a function from pair of element to element. This is incorrect because it would be better to say that's dishonest, right? Because in principle, the pair of elements you pass might not be defined in the map, and then it would be unable to produce an element. So really, if this were like production quality software, we'd be putting a lot more maybes in there and stuff. But I think this is fine. So what we should do, we should say that this is like transition or something, right? And transition is make transition of many rule. Whoops. Where make transition of rules is let m equal, we're going to end up inlining this, I suspect, equal m dot from list of PE for rule of pair, rule of PE in rule. In what order do you want me to pass you? You want the map first in the lookup function? Yeah, so see, we can actually just inline this. So this is our map, and this is our function, look up a thing in the map. Does that work at all? No instance for show. Okay, you're right. I can't show inputs anymore. That's fine. No instance for monoid element. Oh, mempty is no longer correct. We're not making a list. We're making error. There you go. So we're gonna, if we can't parse the input, we'll just give back a function that always explodes. Actually, that's not right, because error, this is exactly the error, the compiler error we're getting is saying, well, error takes a string, and this is a function from pair of elements, right? Undefined. There you go. That's real quality production code. But it should work, right? So if I said let input p's t equal this in t of pair element A element B, we should get back element Q. Yeah, so that works fine. Okay, let's once again. I don't know, like, why exactly today I feel like I should just should be editing my commits instead of adding more commits on top of this parser thing. This one I actually think is kind of a questionable decision, so we'll make it a new commit. Day 14. Use a function instead of a list of rule. So, with this in mind, we now, I think, can write a function that goes one step through the input. We can basically just have a function from input to input, then call it step. Is that correct? That seems right. So we'll just call it step. The function from input to input. Step of input mf equals gonna be a new map, m dot from list width, presumably. Do from list width of plus, of course. Do. And we want to just iterate over the entire input map. So let's say, what are the elements in M? They are a map from pair of A to int. So we'll let P n be... Actually, I need to split this up. So P as pair AB come from m.assocs of M. So we've chosen our first item from the group. And then we will, I guess, let I don't know, I for in between equal FAB, and then we can just return like pair IF1 and pair not F, not that AI1 and pair IB1, right? Does this compile? Pair of element with actual type element. Oh, right. This is supposed to take P, not FAB. Input to input. Okay, you're correct. So the problem is that we're returning just the map part. We're not returning the function. Even though the function hasn't changed, it still is part of the input, which I guess is fine. Is input... It'd be kind of nice if the input came in a different order, wouldn't it? Well, it would make the parser too complicated to do that, I think. Or it would be a nuisance anyway. Input of m prime f, let's say, where m prime equals this stuff. Okay. So let's try this out in GHCI a bit. So if we said, if I have, you know, ABC, and I have the rule that AB turns into Q and BC turns into this, let input equal this in input of m f equal, actually I think I can just, I don't need those parents. I don't know. Let's try it and see. Input mf equals step input. Oh, this needs a, there you go. In M? Okay, cool. It can tell because I'm letting something with a capital letter, I guess, but this isn't a function, it's destructuring an input. All right, so anyway, what do we wind up with? There's a single AQ, a single BJ, a single JC, and a single QB. Perfect. That's what we wanted. So that seems like it's fine. I think we're ready to write part 1 now. We could inline this. It's not saving us a lot of characters, obviously. It's sort of nice to only call the function once. Whatever. I'll just leave it as is. So part 1, we probably want a function called score, which I imagine will be reused by part 2 as well. That takes a polymer of a, really, any type, and returns an int. Let me just double check what it is it wants me to do. What do you get if you take the quantity of the most common and subtract the quantity of the least common? Yeah. So score of m equals maximum of what do I call this? Maximum of quantities minus minimum of quantities, where quantities is m dot elms, I guess is what it's called, of m. Cool. So part 1 then is score composed with find me the 10th element of iterate step. Indeed. The problem is that score doesn't want the function part. That's a little annoying. Wasn't there some other thing where we... Yeah. Maybe this input type could benefit from being a record, and then we could use lenses to make some of this stuff a little simpler. Input of elements is a polymer of element, and transition is a function from pair of element to element. How about that? So if we then add, I know this is kind of overkill to use lenses for this like tiny little thing, but I'm trying to practice like using lenses, and there's some, it seems like they're sort of useful here. So let's make lenses of input, please. Oh, I have to import it from data lens, of course, or control lens. Import control lens of make lenses, and I'm going to want over in a minute. Part 1, leave that alone, make everything else compile for now. Twix is here. Hello, this is a good puzzle, is it? Okay. So we have a lens now for inputs, which means that we can easily apply functions to its elements, basically, without having to do like this whole pattern match and then rebuild the thing together, right? So step of I is, actually I can, step is over transition, no, over elements, run, where run m equals this. Does that compile? I haven't implemented part 1 equals undefined. Variable not in scope f. Oh, right, I do still need the f, don't I? That's a little annoying. Okay, well, maybe we're not going to use the lens here. Step of... I didn't even need lenses at all. I just needed like a record access. Oh well. Step input mf equals input m prime f, where m prime is this. Yeah, the kind of obvious thing is to run this as is to actually produce the whole string, but the exponential nature of the problem, as I explained before you got here, is a pretty strong hint that it's going to ask you to do something smarter for part 2. It gave you a very small step counter and an exponential function. So anyway, so we have this whole thing, and I don't need all this lens garbage at all today. What am I even talking about? We can just say, now that I have a record here, I have an accessor function that can get out just the elements. So part 1, score elements. Parse error? What? On line 16, oh, make lenses is messed up. Yeah, sure. So this parses, or compiles even. What if I were to say stack run? Would I be happy with the outcome of that? 4. That seems implausible. I would be very surprised if the difference between the largest and the smallest element were just 4. Okay. Well, we could parse the, we could do the example input. So if I went to here and I said, oops. I said I wanted to run the example.txt. First of all, what number do I get from this? I assume the wrong one. Yeah, I got 2, and it should be 1588. So something is definitely wrong there. Why? So what I might do then is say part 1, well, we'll leave part 1 alone. And part 2, we're going to produce a polymer of elements so that we can, a list of polymer of elements so we can debug what's happening. Part 2 is take take 10 of map elements iterate step. Cool. So it'll look just horrendous, but maybe we'll get some idea of what's going on. Nope, not really. Okay, let's actually do something even less ambitious. Let's say it's just elements step. What? Oh, just give me a single polymer, please. So in this way, we should just get the results of running a single step. And we should get NC and BCHB, which, you know, by the way, why does it still say 2? Like, clearly, every single thing in the output only occurs one time, right? So this, I don't know what the hell this 2 number is coming from. Oh, sorry, but right. The problem is, of course, that I'm still running 10 steps in part 1. So if I do this, I should get a score of 0. Whoa, wait a minute. How have I not looked at this error? That looks really important for this warning. Line 20, I didn't use n. Oh, that's what's wrong. N times we have pair of AI and pair of IB. Okay. So if I turn these both back to 10, well, let's just turn that one back to 10. It says 791, which is still wrong. But if I go back to saying do it just one time, well, 1 isn't even interesting. If I say 2, I should at least get something where we have some counting that's happening. So it counted to 1. Oh, wait a minute. I think, no, am I? So let me think about this process a little bit here. Because I think this step function might not be done. I have a list of all the adjacent pairs. And so like in my, I think the step function is right though. In my example input, well, let's just look at it by hand, shall we? I'll compare it to what's showing up here. So it's saying that there are 2 BBs. Is that right? We should be looking here. There's these 2, and that's it. It says there's 2 BCs. I see that one and that one. Oh, this isn't even going to tell me, though, whether I'm right? Because even if I find all the things I was looking for, there might be some stuff that's there that I didn't find. Okay. There's 1 BH. Yeah, there. 2 CBs. Here and here. 1 CC. Yes, that's correct. 1 CN. Yes, correct. 1 HC. Here. And and 2 NBs here and here. That looks fine. Yes, and now Rubix points out the thing I'm about to do next, which is, okay, I've confirmed that, like, this, every element here matches up with the stuff that shows up in that I was expecting, but I haven't confirmed that the number is right. So what if I said, well, how many pairs are there? 2, hang on, there you go. 2, 4, 5, 7, 8, 9, 10, 12? Did I add wrong? 2? 12 is... No, 12 is the right number, because there are 13 total elements after adding 6 in between the 7 starting things. So this, in fact, is, I think, exactly correct for step 2 of the example input. But... well, no, it says the score for that is 1, which seems correct. Oh, wait, I'm dumb. I'm dumb. Okay. All right, the problem is in the scoring function. I've just realized what it was. The problem is, I counted the most common and least common pair, because that's what's in my map. But that's not what they asked for. They asked for the most common and least common element. So I have to split the pairs up into their constituent atoms, and then I should be good. M.elms of m.fromList with plus of do pair AB comes from M, a soaks of M, and then we say A N B N. M.soaks. No instance for ord A. Rubix asks, how are you counting up how many times each element shows up without double counting? The string BCB, pair BC, pair CB. That's a good point. So the answer at first is that, well, I was just not counting elements at all. I was counting pairs, and that was no good because it was wrong. But I was about to start making the mistake that you're pointing out. In fact, I think as soon as this starts compiling, it would I would have that same problem. I'm counting. Now, I could count only the first element of every pair. And that's fine, because each pair appears only... The first element of each pair appears exactly once in the input. But the last element doesn't... The last element of the string is not the first element of any pair. Right, and so I was about to say what I think I'll do is just count the first element of every pair and then, like, special case the last element, which, good news, the last element of the final state is the last element of the input. Because we never... I don't think I said anything about scrapping my code. Now, okay, hang on. If we count... Is there some way to do this without a special case for the last or first character? I don't think so. I think we're just going to count the first of every pair. And we'll just say like that. The problem is that we also need to know what the last was. So I guess score now kind of needs to take an input instead of a polymer of A. And then we'll break it apart. Input MF. So we can throw this away. And now we're almost there, but we don't have a special case yet for the last element. And I suspect that Eric will... Yeah, so for example, if we look at the example input, Eric has cleverly arranged that the first element and the last element are the most and least common, so that you can't get away with failing to do the special case at the end. So So what I'm thinking I should do, it seems kind of gross, but hear me out. First of all, let's change this to take a B instead of A. We'll count the second half of every pair. Is to just add to input, like, what was the first character? And then we'll count the second of everything and an extra 1 of whatever the first character was, basically. First is an element. All right, whatever. And we have to m dot do something to the map to add 1. How do you alter? Do I just want to use insert with, I guess? I guess I do. Yeah. M dot yeah, I've already made that change, Rubik. You can see that I'm looking at just the B and I'm getting first character from the end. M dot insert with plus of I1, I guess. It's starting to look a little gross. And I need this input function. There you go, undefined again. Genius. Top level Haskell programming. Oh! The fact that I'm reusing something between... Okay, I have to be a little bit fancier here. Well, not very, really. I just can't have, like, I can't just map a constructor anymore. I have to make input, where make input of my polymer is all the way down here. Plumbing the first element through is suddenly annoying. Why did I did my parsing, or I did my turning the string into a map as part of the parse. And so now, like, I don't have the string where I need it anymore. Am I on, like, is my delay enormous? I feel like Rubik's is making comments about, like, stuff from 5 minutes ago? I don't know what's going on. Usually I don't have so much lag. So, right, my problem is that the polymer is now, like, okay, we're gonna have to inline this make polymer function, I guess. Many element of ease and f equals input of make polymer ease f and head ease, basically. And we'll move all this stuff up here. Well, I hope you had fun at your Christmas party, or you say Christmas? Some party, right? Yes, Christmas party. Okay. So now, does this still compile? Probably not, right? Make polymer is not in scope. Right here, though? Ah, down here. This I don't need it. Where? What even line 27 it's sad about? Here. So m.insert with, oh, that should, no? What order does m.insert with take? Insert with, I would think it would be this order. Function key, oh, no, it doesn't want a tuple, of course. It wants that. Key value map, okay. It compiles. So if I go back and I do stack run now, we get 5, which is more realistic, I think. Let's change it to be, how many times does he step in the example input? We'll just check that we have it right. 4 times. And we get 18. That's... yeah, there's warnings about unused variables, but I think I actually am ignoring at least most of them on purpose. Oh, that one's spooky. Here I'm ignoring F, that's fine. And here I'm ignoring A on purpose, because I only want to count the second part of every pair. I should make that more clear in here. This, what's the eye that's shadowing? Oh, this. Is that okay? It is okay, I think, actually. But I'll just give this a better name. Between. Oops. And what else was it warning me about? The F in score is unused. It's fine. We still get complete. Oh no. I don't know that that answer is wrong. Because the actual example input is running for 10 steps, right? So this should yield 1,588 if we're lucky. It did. Okay. Crisis finally averted. So we'll just change this to be input.text, and we'll be on the gravy train in no time. $2,740. That is a believable number. That's the right answer. Great. The funny thing is, all this stuff about tracking what was first and last, like, we probably could have just added one to whatever. No, because we still had to know which one was first. Yeah, okay. We could have tried, though, adding one and subtracting one, depending on whether the first or last character was most common. It would have come out okay. Because I suspect the first and last were the most and least common. Okay, so we need to run the polymer for 40 steps. And how big a number is this? Yeah, I mentioned earlier in the stream before you got here that this is basically like lanternfish redux here. It's the same thing where you're recognizing that pairs are sort of fungible. So is this like, can I fit this in an int32 or int64? Probably, right? But like I might as well use an integer. Ta-da! I think that should be it. Header, there you go. Anywhere else I have ints? Nope. Okay, is just score of run it 40 times, iterate step. Oh no! Oh, I said it should return unit. Yeah, I assume it doesn't. It probably doesn't overflow int. But it's kind of safer to use integer. So let's just write a little function here. Solve function from int to input to integer, and solve n is score and iterate step, and I want to say this is solve 10 and this is solve 40. There you go. I mean, the difference between int and integer is that int is defined to be at least 29 bits, but in practice is, sorry, it's, how big is it defined? It's defined to be like 60 something bits at least, and in, I think, well, let's look this up actually. But I mean, integer is unlimited precision, and int is about a machine word, more or less. So what does Haskell guarantee you get out of an int? Yes. So an int is a fixed precision integer type with at least the range from, it basically guarantees you get at least 29 bits, and depending on your compiler and system, you might get more. And in fact, in practice on GHC, on any modern system, you get 64 bits. But the Haskell standard makes room for an int that might be only 32 bits, and that furthermore, they might use the lower bits of for something else. And so this number is definitely not large enough to fit in like a 29-bit int. It's too large, rather, to fit in a 29-bit int. So, like, if you rely on the fact that int is 64 bits to get the correct answer, you're technically not writing portable Haskell, if there is such a thing. Whereas integer is arbitrary precision, can run, can go very, very large. We can say extra credit, for example, is solve, 200 or something. That should be fine. Uh-oh. Oh, I didn't write enough ands. So, for example, we can run this. And this is obviously too big for int. But it fits fine for integer, because an integer is a big int, basically. The internal representation of integer is like a sum type, where it might be a normal int if it's small enough, or it might be basically like an array of bytes that it does fancy math on. Okay, anyway, so we're done with this. So let's go check and see whether this is the right answer. Of course it is. Very good. So did I do anything weird here? Wait a minute. Did I never commit part 1? Ugh. I forgot to commit part 1. Oh no. Day 14, parts 1 and 2. Whoops. So I was planning to do day 15 tonight, but it's getting kind of late. And 15 is not hard, but it's not short either. So I think I am going to call it quits here and try to catch up on day 15. Ugh. I'm busy tomorrow night. I don't know. Depending on how short day 16 is, I might do them out of order, but I probably won't be doing 15 tomorrow night. So, like Thursday night, maybe? We'll see. Well, we can push that. I mean, basically, so like, I don't know, 15, right, is like implement a search algorithm. And I've implemented A* enough times. I could go find one in my old, find an implementation in one of my old Advent of codes and reuse that. I think it will be instructive to just re-implement it again, and it's like good practice, but I don't want to do that tonight. So we're gonna wrap things up. Oh, I meant to show you guys. Here's day 15, but it's like find, these are the costs in a graph, and you want to get from top left to bottom right, going through the lowest total cost. And what do you like? I guess you can just like, so I would be implementing A*, right? Because A* is not that hard, and it's good enough to do pretty much everything you need to do. In principle, I think we could use like, what do you call it where A*, where you always assign the heuristic to be 0? I think you call it best first search, maybe? Greedy search? I'm not sure. It's not breadth first or depth first. I think they would call it, oh, but best first, I don't know. You could also like you could probably use Dijkstra's algorithm on this, right? You've never implemented A*. Well, tune in a couple days. It's not that hard, and it's kind of a cool idea. It's basically just breadth first search in terms of path length, Michael. But that's wrong, right? That might produce breadth first search in terms of path length. What does that mean? Path riskiness, or like actually number of cells entered? Because number of cells entered, I think, is wrong. And if you think of it in terms of length, like where like you count this as a single step of length 3, yeah, where length is the cost. But that's, I just wouldn't call that breadth first. Like I don't think that's what it is. I think they would call that best first in the literature. What is best first search? Like what is that? Yeah, so okay. I've already donated to Wikipedia. Please leave me alone. Best first search is a class of search algorithm which explore the graph by expanding the most promising node chosen according to a particular rule. A heuristic evaluation function may depend on the so the information gathered by the search up to that point. So I think that best first search, greedy, yeah, so greedy BFS. If the heuristic is better than the parent, otherwise the successor is inserted into the queue. Yeah. So I don't know. I guess they call this greedy breadth first, even though it's not. Or no, this is greedy best first, of course. Haha, yes. So it is BFS, but the B stands for best, right? Breadth first is like a specific thing where you actually are talking about the number of nodes traversed, and would not be a correct answer to tonight's problem. A star is just the greedy best first search where you have a better heuristic, basically, I think. Actually, I still expand the first successor of the parent. Oh, I see. This is a weird one. What a weird algorithm. Why would you implement this? Is there a difference between A star and Dijkstra's algorithm? Rubix asks. Yes, the difference is they're totally different. No offense. I always have to like I know A star well enough to just like do it without reading anything. I always have to look up like what is the deal with Dijkstra's algorithm. Dijkstra's algorithm finds the shortest path between all pairs of nodes in your graph, and then uses that to like give you, okay, well here's the shortest path from A to B, where those are the things you asked about. I think, right? A more common, yeah, Dijkstra's original found the shortest path between two given nodes. Oh, so it's not from all pairs, but from a start to all other nodes. Okay. Finds the shortest path between the node and every other. So the main difference is that Dijkstra's algorithm searches the whole graph. It finds you how to get to places even if you like don't care about them. Because if there's a very fast path to like, okay, let's look at this graph here, right? Michael says, if you imagined your cost for each step to actually n pseudo steps, cost, yeah. I think that's fine. That's a fine way to think of like a heuristic or a cost weighted search as like breadth first. I think that's fine. If you want to think of that as breadth first, like I guess you can. So the thing with Dijkstra's algorithm is it like we're starting from A. Is that what's the idea here? I don't really want to pay attention to the shit they're drawing on here, but suppose we want to get from A to B, which I think is what they're asking for. It finds the shortest path to everywhere because they're like, okay, let's say I found a pretty good path, like 9 to 9 to here, right? But, there might be, maybe this is like 9 and this is 1, 1 or something, right? Or maybe this is 9, 2 and it looks very promising, but then this is weight like 100. And so the knowledge of the shortest path to anywhere might turn out to be useful. Whereas A star searches towards a specific endpoint and stops when it finds the first path there, and arranges to first path there? The first time it gets there. First time it visits it, yes. And arranges to explore paths to it in increasing weight order, so that the first one you find is the cheapest one. But it also lets you make use of a heuristic that can make your search go faster if you have some guess of how close you might be to the exit. So it can be more efficient than just greedy best first if you have like some idea that like, okay, I'm, let's where am I? Say I'm here, right? Or we got here. There are kind of 4 nodes you could go to next. You could go left, right, up, or down. And any of them could be correct, assuming we didn't like just come down to get here. And so a best first search would, like, or breadth first even, would explore all 3 of them kind of simultaneously. Or not simultaneously, but without a bias. A star uses a heuristic and says, well, can you estimate how far it would be from here to the exit? How far it would be from here to the exit? How far it would be from here to the exit and here? And uses that to bias the direction it searches in. And so a typical heuristic is just like the straight line distance. Like we know from here to here is at least cost 2, maybe more. This is from here to the exit is at least cost 2, maybe more. From here to the exit is at least cost 4, maybe more. And likewise here. And so while we may wish to explore all of these, it's better to explore these 2 first because they're somewhat more promising. For an input like of this size, that's not really going to be that relevant. It's small enough that, and we don't really care about shaving off, microseconds or milliseconds. But it is a pretty simple refinement on top of greedy best first, or Michael's cost-weighted breadth first, that I think it's always kind of nice to add, and it does go a little bit faster, usually. I think it's actually guaranteed to go at least as fast as greedy best first. Is that right? I think so. Assuming that the heuristic is cheap to compute, of course. Yeah, it stores all generated nodes, so but I think, I think that's true of like, well, only if your estimate is good. Yes, your estimate must never underestimate. It must never overestimate. If you overestimate the heuristic, then the algorithm is unsound and should not be used. But the kind of thing that I like about it is that if your heuristic is always 0, if you just say, oh, I estimate that the next step will take me directly to the exit, that's a valid heuristic, and it gets you the kind of best first search that Michael was talking about. The degenerate case where your heuristic is always 0 is this other algorithm that is also correct. And if you use a heuristic that is any better, you get slightly improved performance. better search where it doesn't explore as many unpromising paths. So, okay. Well, we'll talk about that in more detail. Oh, I forgot. Before we go, I was gonna show off a thing that happened in yesterday's thingy. Because I didn't want to do it right at the beginning, like there was nobody here. But something that I thought was cool, and maybe Rubik's will appreciate that more as like a Haskell aficionado, perhaps? I don't know. I know Michael's not that familiar with Haskell. So I had written kind of a not very pleasant fold function. This is the new one. Let me actually just get out of here. Git log. And if I say day 13, where did I start? This is where I finished yesterday. So we said git diff dot of that. So we had this kind of gross fold function where we were folding a thing in half, and I kind of had to do like a bunch of repeated work here, right? Where I said, oh, if you're transforming x, then destructure the point and check the x coordinate, and if it's out of bounds, then build a new point with the same y and a different x in the same way, and then I have to do the same thing for y. And I realized that this is exactly like, if you were doing this in a language other than Haskell, well, it depends. This would kind of suck in Java as well. But in a language like, say, Python or Clojure, where you can kind of reify field accesses, where you could say, oh, my point is just a map where the key is x and y, you could easily say reflect the x coordinate over this axis, or reflect the y coordinate over this axis. And so in Haskell, it's kind of hard to do that because fields of records are not really first-class things. But lenses make them fairly first-class-ish, almost? Not quite, but you can do a lot of the same stuff. So make lenses of point gives you a function, two functions, one for each field, named x and y, which is kind of a function that can be used as both a getter and a setter for that field when applied in the right way. And kind of the most common lens function that I ever use is over, which just says, given an accessor function and a function to apply to the field accessed by that accessor, it gives you back like a function from the outer field. So field access is an accessor where we give you either x or y. Reflect is a function that takes the x or y coordinate and gives you back a new one. And so over field access reflect is a function that takes a point and gives you back another point. So that's kind of nice. And then you can, you don't have to special case or write. You don't have special case x and y separately except for right here in field. You can treat them uniform. And I think I made a couple other changes. I made it a little bit easier to read by using a space instead of a dot there, but other than that, nothing much. So that's kind of nice. I'm still like, this year is the first year that I like kind of know what's going on with lenses and know how to use them at a basic level. But I don't do anything particularly fancy with them. And advent of code, the data structures tend to be simple enough that there's not really much call for lenses. But today, there was a little bit. Not today, yesterday. So I just wanted to show that off while there were people here. And now I really am going to get out of here. So thanks for joining me, everyone. And I'll see you next time, which will be in maybe a day, but probably 2 days. Thanks for watching, and I'll see you next time.